So we're gonna start right now, and thanks for coming today. So let's get started. I'm gonna talk a little bit about event-driven auto-scaling Java application for the next 48 minutes. So let's get started. So my name is Daniel. I'm working for Red Hat as a developer advocate, and specialize like a bunch of the Java stuff, like some cloud native runtime. If you already joined the previous session, Sebastian. So one of my duties is Quarkus stuff, and then Spring Boot, and then JavaScript, bunch of the other stuff. I've been spending a lot of time to bring more Java application into Kubernetes and bunch of the other Kubernetes ecosystem. So one of my duty is the Cloud Native Computing Foundation CNCF ambassador. So some people told me you should be like a KubeCon Amsterdam this week. However, I'm here because I'm pretty much more care about developers. And then here's my contact information, my some book here. You can follow my Twitter, Daniel30, and then my YouTube channel, and then my GitHub repository. Just feel free refer anyone, anything you want, and then just feel free to do that. Okay, so it's a really good fresh ride. So how many people actually have some experience deploy your Java application or any kind of application into Kubernetes? Awesome. Yeah, we got a lot. And then, so as you know, so the beauty of the Kubernetes is kind of auto-scaling. So whatever your deploy application in the workload and then incoming network traffic, Kubernetes automatically scale out based on like a utilization, like a resource utilization, for example, CPU, memory, etc. And then here is the fundamental architecture, how to auto-scaling on your Kubernetes stuff. So here's an example application, like a retail, for example. You got a microservices like a Java, .NET, Python, whatever you need. And then like an inventory application, catalog, order, cart, and then every single microservice is running on Kubernetes as a pod. And then if you wanted to scale that application auto-scaling capability, you need to set it up Horizontal Pod Autoscaler, aka HPA, or like a BPA, things like that. But in reality, it's not the end because the application actually should be and can be auto-scaled based on external services. For example, Apache Kafka for event-driven streaming, and then Prometheus for metric-driven auto-scaling, and then some kind of event-driven or metric data from the cloud provider. For example, the Amazon CloudWatch, and then Azure Monitor. There are many kind of external services that you need to consider about your auto-scaling time. So how to change, how to redesign your Kubernetes auto-scaling architecture based on that requirements? So here is the maybe easiest way because you already hands up. You got some experience Kubernetes stuff. So so Kubernetes allows you, excuse me, Kubernetes allows you have custom metrics. For example, here you can create the Amazon CloudWatch metric adapter, or the other like a Prometheus metric adapter, or Azure Monitor metric adapter. But the one thing here is you cannot create Kafka metric adapter directly. So that's why you need to liaison like a Prometheus between Kafka cluster to get a metric adapter, and then that metric adapter allows your application scale up and down or in and out. So this is a way how to redesign your auto-scaling based on Kubernetes. But there are one problem and big challenge for you. You can only enable one adapter at one time in the single namespace. When I just looking at the backend, the application, so the application actually, as you can see, multiple microservices, but you cannot say my all microservice application should be scaled out based on one external services. So that's not reality use cases. Here is the goal. So my order application actually scale out based on Kafka metric, Kafka messaging. And my payment service is actually based on scale out based on the Azure monitor. This is a real story. How to handle that? So let me show you how to redesign your architecture. But for that, so I'm going to bring that up to KEDA. So KEDA is a literally Kubernetes event-driven autoscaling. So one of the CNCF project to handle the autoscaling based on event-driven metrics and event-driven streaming data. It's pretty simple. You can install the KEDA based on operator or Helm chart on your Kubernetes cluster. And then you don't need to change any kind of existing Kubernetes resources because it only handle your existing Kubernetes resources, for example, deployment and the batch job, things like that. The Red Hat and Microsoft and then put in a lot of effort to design and develop this project. And this is one of the incubating projects right now in CNCF. And then we recently released a couple of months ago to 10. There are a bunch of these, some autoscaler adapter, like more than 60. For example, the Kafka, and Apache Pulsar, and the Prometheus, and RabbitMQ, and AWS bunch of services. You can actually set it up multiple external services to scale out your application running on Kubernetes, which is really cool. So with that, you can redesign and make it better, your autoscaling Kubernetes capability. As you can see, I just deleted all HPA stuff mapped to each single microservices here. However, the new KEDA infrastructure is create a scaled object, which is managing your autoscaling capability. I'm gonna take a look at a little bit more detail, the 10,000 feet architecture just in a minute. And just take a look at here. Now you can enable multiple external services into multiple microservices running on Kubernetes. And then one of the good things is KEDA only scale 0 to 1 and 1 to 0. That's it. However, in reality, you need to also care about like more than one replication. For example, my application should be scaled out like maybe 1,000 pods based on network traffic. But KEDA only just handle 0 to 1, 1 to 0. How could do that? So that's the one of the benefit of KEDA. KEDA actually invoke existing HPA. So the KEDA fundamentally managing scale 1, 0, 0, 1. However, after scale 1, and then still you got a more incoming network traffic. So KEDA actually calls HPA controller, and then HPA scale from 1 to like whatever you need, like 100 or 1,000, even 10,000 pod, as long as your Kubernetes allows that. And then here's some 10,000 architecture, what kind of component KEDA has. So there are a metric adapter and a controller and a scaler. And then as you can see in the bottom of the line, so here is the 0 to 1 and 1 to 0, just like I mentioned earlier. And then after that, so KEDA just call existing HPA like autoscaler. It allows the application scale to more than 1. And then you just only need to create new resources like a scaled job and a scaled object, which specify what is your trigger and what is your target Kubernetes resources here. So here's a quick example, scaled object, and you can see here the scaled target, which is one of the Kubernetes resources, and then what is the target, like what is the trigger, like a Kafka cluster, or the Prometheus, or a messaging broker, or some cloud provider, like a monitor, like a CloudWatch in AWS. So what about the serverless? As our title today, so we're gonna do event-driven autoscaling, specifically serverless Java application. So KEDA is not focused on serverless. It's just scale up and down based on event-driven metrics. So this is I'm going to showcase another project in CNCF. It's a Knative. So Knative allows developer as well as operation team manage your application like up and down, just like a serverless behavior like Amazon Lambda, Azure Functions, and Google Cloud Functions. But one different there are so many different things actually. A lot of people ask me, hey Dan, I just learned about Knative project, which allows me to deploy my application as serverless. Like I don't have any network traffic, like incoming network traffic for specific time period. My application power will be scaled down to 0, just like Amazon Lambda, which is really cool. However, I don't think that's really good project or tools for my millions of event-driven messaging processing. That's why I'm looking at KEDA. But KEDA is not 100% serverless capability. So there's some people interchangeably use the KEDA Knative, and then they said it's kind of exclusive way to use two different projects on top of the Kubernetes, managing your event-driven application with the Kubernetes. So here's a big difference is some bullet points here. So KEDA, you don't need to change any existing Kubernetes resources. However, Knative, you need to change and rewrite existing Kubernetes resources for Knative services, which means as a developer perspective, you need to rewrite your boring Kubernetes YAML file, which is not fun. And then there are a few bunch of different things, but I'm going to show the live demo what different things are there. So today I'm going to try to demonstrate 4 different demos. And then the first demo actually, I'm going to use the HPA, just Horizontal Pod Autoscaler, and then how do HPA works to autoscale your existing application. I'm going to use a Java application on Quarkus. I'm going to explain why I need to use a Quarkus for Java application rather than the other Java framework. So the first architecture pretty simple. In the right-hand side, you can see that. So only Kafka cluster there. And then my Java application will consume the millions of messaging from Kafka cluster. So I'm going to stop presenting, and then so go to demo stuff. And then here is my Kubernetes cluster, which is the Red Hat developer sandbox. When you go to developers@redhat.com, and then you can find that first thing is the developer sandbox for Red Hat OpenShift. And then as you can see, so when you sign in for free with your email address, and then you can verify your identity with the email address or your text message, and then we will give you free Kubernetes cluster for 30 days. And after 30 days, you can reactivate that cluster again. It's really like a limited, unlimited offering our services there. So I'm going to use that kind of stuff as well. But today I'm going to try to some more cross-admin permission to showcase a little bit more details. So I created a new project here, the namespace Kafka-HPA. I already created my Kafka cluster with the topic. I use operator to install Kafka cluster to save my demo time. And then here's my Quarkus application, two Quarkus application. So first Quarkus application, I just used the latest version here, Quarkus 2.16.6. So we're gonna release Quarkus 3 end of this month. Really spoil Quarkus 3. We integrate and implement a bunch of the new awesome features. For example, the Quarkus 3 supports micro profile 6, and then Jacquard 8.10. You cannot find Java X anymore. And then we're gonna integrate virtual thread based on Project Loom. And then there are some Linux kernel integration programming, not using JNI. You can use the read directly. And also, you can actually use UDP protocol, get some more high performance rather than TCP protocol. There are many great features coming up in Quarkus 3. And then I'm going to back to my application. The application is pretty simple here. It's some just simple application. And then it just consume the messaging from Kafka topic, the topic name here, my topic. And then I just print out logs, what kind of message I just consume. And then here's the first reason why I use Quarkus rather than like a Spring Boot and the other stuff. So I've been doing a lot of time to Spring stuff for more than decades. And then when I try to develop reactive programming with the Spring, I need to rewrite existing all Spring Boot application based on Spring Reactive. Also, I need to integrate like a Spring ecosystem, for example, Spring integration or Spring Cloud or even Spring Function, etc. And then that is a big challenge for like a Java developer to do reactive programming. And the Quarkus actually was born based on reactive engine, which is Netty and BirdX. But Quarkus also allows developer to develop non-reactive programming and reactive programming at the same time. So how do you manage reactive and non-reactive at the same framework without adding on like the other ecosystem? You need to add the relevant dependency Quarkus calls extension, and then add some relevant annotation. So for example, this method, I just public void receive is pretty much a normal method, but I add one annotation incoming. This annotation allows me this method just consume the Kafka message right away, like reactive programming. And also you can add like outgoing annotation, and then you can just send out your like a JSON format data into your Kafka topic or messaging broker, and then any kind of the messaging server. You can also edit it like a channeling when you create like a pub and sub server. So it's pretty much easier when you develop reactive programming. You don't have any kind of experience of how to develop reactive programming before. And then, so when you go to resources and then my property, I just set it up my old topic and then things like that. Here is my topic. And then I'm gonna set it up like a serialize, deserialize, and then here's my Bootstrap server. So this is a Bootstrap server. It's not fully qualified domain name like a www.daniel.com. Now this is just literally Kubernetes service name because I already deployed the service, the Kafka cluster on top of the same namespace. So that's why I just use my service name here. And then a few bunch of the OpenShift configuration. So Quarkus OpenShift extension allows me to avoid many boring steps to packaging my application, containerize the application, as well as deploy my application to Kubernetes. With a few here key and value, make that happen, literally. So this is I'm going to deploy the Kubernetes is true, which automatically generate like a Kubernetes resources like a YAML file, and then targeting OpenShift or the Kubernetes or even Knative, and I'm going to build my application into Docker, and then I'm going to use a TLS termination, and then print some request remit stuff here. Because when you generate new Quarkus project, it automatically generates Docker file here for JVM and then like a native compilation as well. And you can find here legacy jar, and then because Quarkus actually generate fast jar, if you attended the previous session, the Sebastian, he actually showed the fast jar under target, under the dash app directory. The Quarkus actually rewrite Java class loader, and then it will make it faster a startup time. And then we call that fast jar rather than like a Uber or a fast jar. However, the legacy jar is to generate the jar file just like a Uber jar, just right under target directory. The reason why some deployment environment only reporting into jar file just under target directory rather than two levels. So that's why it's your preference. And then native, just executable running on GraalVM. And then we also provide some very small micro image as a base image when you containerize a native executable file. All right, so let me go back to my terminal, and I'm going to try to deploy my application. I'm going to make sure I'm going to write project Kafka HPA, which is the same namespace. So I'm going to use to Quarkus CLI today. You can use the Maven command line or Gradle. But one of the reasons why I use Quarkus CLI, which is pretty much easier to manage your application deployment and then packaging and add the extension. You don't need to remember all Maven and Gradle argument. It's pretty much easier to use that. They are also provide auto completion feature with the Quarkus CLI. So today I'm going to use OpenJDK 17, and then it's automatically containerize the application. So once I deploy the application, I'm going to try to do the performance test here. So luckily, the Kafka cluster already include the Kafka processor performance bash script inside the Kafka cluster. So I'm going to use that Kafka bash script here, and then targeting topic is my topic, and I'm going to generate this dummy record, like a 1 million record, and a 5 parallel process. So in the end, I'm going to generate the 5 million dummy record, and then that record will be consuming in my Java application on Quarkus. And then we're going to take a look at how faster the Quarkus application scale up based on HPA capability. So once we deploy, and then now we containerize the application, and then that application pushing into OpenShift cluster. In the meantime, when you go to target directory, you can see Kubernetes directory automatically generate, and then you can see JSON or YAML file. It automatically generate like a Kubernetes resources, like a deployment and the services, and then the other stuff. You don't need to even run kubectl to execute this Kubernetes YAML file. So Quarkus CLI and Maven like a Maven clean package automatically containerize, image, and then run this YAML file into your targeting Kubernetes cluster. Okay, I just deploy. And then when I go back to UI, and then now I can see my Quarkus application here. And now let's try to take a look at the logs here. So just here, my application 2.16.6, and then the bunch of the extension already there, and the startup time 5 seconds. And then my topic name, my topic is automatically channeling, and then back to here, and then go back to my script. You can run this YAML file using kubectl or OpenShift command line, or when you go to OpenShift cluster, a developer sandbox provides the beauty of the GUI feature. I just import here. Not that one. It's the wrong one here. Okay, here's the job. But for that, I needed to, let me go back to here. And then my application, as you can see that an up and down arrow, which means I can just scale up and down manually, because this is not actually set up auto scaling. So let me try to set up the auto scaling here. So targeting my deployment here, the Kubernetes Quarkus EDA demo and the min-max 110, and then CPU utilization 70%. It means when the your CPU utilization in this pod exceed 70%, the HPA will decide, okay, it's time to scale up. So I just set it up, and then back to the UI. Now you can see it's auto scale is set it up. And back to my application, I'm gonna copy the bash job, and then back to here, and then create a job. Back to the topology view. Now you can see new job is just created. It will scale to 5. I'm going to create the 5 different process to generate more like a 5 million code. And then go to resources, and then just create a new one. And then when you click on one of the running pod, and then like a view logs, now you can see the dummy message generate every single second until it reach out to 5 million. And then back to the topology. And then my application still one. And then when you go to Quarkus, so what it's doing right now, you can see that there are many messaging is coming down your Java application. However, it's pretty much busy. So I think it's starting to scale out right now. But when I go to horizontal configuration, And now you can see that the target is 70%, but current is a 0, not even nothing in there, which means the HPA takes some time to figure it out to utilization. So I would say it's Kubernetes HPA is so stupid for event-driven application, right? So let me just repeat a little bit more because it takes some time, maybe a couple of minutes to the HPA to figure it out. It's the right time to scale out. Let's go back to my slide deck, and here we go. So how do we optimize? How do we redesign, make it better? So we're going to redesign using KEDA. So now you can see that our autoscaling architecture really changed that. So now we have a KEDA here, and the KEDA actually pooling model. So it's not intervene directly the external services. However, the KEDA keep gathering the metric data from external services, which is a Kafka cluster here. And in the meantime, my application, Quarkus application, keep consuming data from Kafka. And then sometime later, KEDA just let my application know it's time to scale out. So this is really pretty much better based on the triggering, based on event-driven messaging from Kafka cluster. So let me go back to demo environment here. I'm going to change my namespace here, go to like a Kafka KEDA. Once again, there's no application at all, only Kafka cluster is exactly the same thing. And I go back to my project, and then I can deploy my application using like a YAML file. In this case, so the deployment name, the Quarkus demo, EDA demo, and then here is my targeting a Kafka Bootstrap server as an environment variable, which is the same thing. And then I just copy my deployment YAML, and then back to my web browser, and then just copy it with that. And now you can see that my Quarkus application already running because the image already pulled down in the previous namespace, which Kubernetes already know where the image is. And then you can see that just make sure the same Quarkus version and same extension because this is a performance testing. So I don't want to like some cheating my application stuff. So one thing back to my application, as I mentioned earlier, I need to create a scale object here. Scale object, what is your target resources, which is my deployment name, Quarkus EDA demo. Back to the UI, the same Quarkus EDA demo. And then, so here, just what is trigger to autoscaling is a Kafka cluster here. So I just copied that, and then in the meantime, it's all still up and down, like a manual stuff. When I create the scale object on KEDA, and then back to my topology, and now you can see that. So autoscaling automatically set it up because as I mentioned earlier, the HPA automatically created based on KEDA. Previously, I created HPA object manually. However, KEDA actually created for me. And then I'm going to try to run the same performance batch job here. And then back to here, topology view. And then now it's created already 5. And then back to the application. And when you try to go to Quarkus app, now you can see really busy starting the job. It's many millions of data is coming up. And then back to the topology view. And then just give us a moment when it's actually scaled out. And now you can see it's already scaled out to 4. But previously, HPA, it takes some time to scale out. It's already 4. Let me go, and then in the meantime, it's scaled 8. So a little bit faster than HPA. And when I go back to HPA, let's take a look at what happened in there. And then go to HPA project. My job is already done. No more generating messaging. And then go to application. It's still 2. And then go to HPA. As you can see here, targeting is 70% because it just scaled out 2, and then it also takes another time to figure out the CPU utilization based on trend and not really scaled out. So even if you have a keep coming job, like a messaging, millions of messaging, you're crazy busy. However, HPA doesn't know that. So that's the problem. Just like your manager, as an individual developer, you got a lot of job to do every single day. But your manager doesn't know that. Keep asking, hey, you got to do something due right now by today or tomorrow or by end of this week. It's the same thing. So let's go back to KEDA namespace. And now you can see that it's already scaled out to 10 because 10 is the maximum. That's how I set it up. So this is the reason why the KEDA is pretty much better than, but it's not really serverless because I didn't deploy this application as serverless. So I'm gonna go back to slide and then go to next demo before that. So how do we handle serverless application for event-driven? So that's the reason why the Knative project came out. I already mentioned earlier. And then now we're going to a little bit change the event-driven architecture here. As you can see, the Kafka cluster, but there's one thing different thing is the Knative project actually two different components. One is the Knative serving, which allows you deploy your application as Knative services, which is just literally serverless. And the other one is Knative eventing, actually managing your eventing source. Like an event source could be Kafka or like a ping or many other like a messaging server, many other different event sourcing you can handle that. And then as you can see, first of all, you need to deploy new Kubernetes resources, which is a Knative services, which means you need to rewrite the YAML file. And then, so Knative has its own autoscaler. The Knative not going to use the HPA. They have own autoscaler component. And then, so Kafka actually sending out messaging to Kafka source. And then Kafka source just transport that message to application. This is a little bit complicated, but this is how the serverless on Kubernetes works. So let's go back to demo environment and change namespace once again, like a Kafka Knative. And then here's my new project. Let me try to reopen the other project here. Once again, I'm going to try the same project, the 2.16.6, the race 1. And then when you go to here, dependency, I'm going to use reactive programming and the Kafka message extension, exactly the same thing. And OpenShift extension, which allows me generate all the Kubernetes YAML file as well as a containerized application. And then when you go to Java file, it's really you need to change like a cloud event stuff. So I don't have any business logic here to process cloud events. So Knative event recommend to use cloud events. The cloud event allows to have more standard way to managing your messaging programming. So there are many different type of messaging definition or specification, for example, JSON format, or protobuf, or binary. So there's no obligation each end user to create event messaging. But the problem is you need to transform from messaging type A to messaging type B, whatever you need. But cloud event is to provide the standard way to definition of messaging on the cloud. And so you don't need to transform between different messaging format. So that's why whenever you use your Knative event, you need to use cloud event messaging format to process your messaging or streaming, things like that. So which means developer standpoint, you need to rewrite your Java method, as well as you need to rewrite your Kubernetes YAML file to deploy application as Knative services in the end. So luckily, Quarkus is pretty much easier to generate the Kubernetes resources. That's the second reason why I use the Quarkus today. And then when you go to application property, and then this is another reason I use Quarkus. So here's a target environment. Previously we used OpenShift. Now we're going to use a Knative. when I set it up Knative as a target environment in Quarkus configuration, it automatically generates Knative YAML file, which specify all Knative services manifester. And then let me try to go to my terminal and then change my Knative project and then change also project Kafka and KEDA and Knative. Okay, I just changed my directory, and then I'm going to try to build my application once again. So once we deploy that, and I'm going to try to create a new Kafka source as a sink. So I just defined the Kafka source here under the kube directory. Here's Kafka source. In the Kafka source, as you can see, we set it up. Where is my bootstrap server of a Kafka server? That's why when I go back to application property, in the previous project, you can see that, oh, where's my Kafka? So you can set it up the Kafka bootstrap server in application property. That's the known way how to set it up, your Kafka integration with the Java application. However, you cannot find that configuration anymore as long as you use Knative project with your own application. Because we're going to use create Kafka source with literally liaison between your application and then Kafka cluster. So this is the way how to use that. And then what is the topic name here? And what is where did I sync this application for reference? That is the service name of my application. So this is literally set it up out of your application. It's to make your application simplify to set it up like Kafka integration in this end. So I need to create this one as well. So push application, and then it's just done. And then it will show up to Knative project. Oh, I actually do that Kafka Knative. Okay, so let's switch the project name. So let's try to that. It actually is supposed to be deploy Kafka Knative and KEDA integration, but so let's try to rebuild it because I don't have enough time to rebuild, recompile again. I think so. Let me try to recompile because the project name is different, and then we got some error because when I go back to application, it literally go to here and an image group name, which is the same name of namespace, but I actually mistakenly deploy Kafka KEDA Knative project, which is different name of a namespace. So let me try to change the project once again, Kafka Knative, and then build again. In the meantime, let's go to delete this service, and then try to make a cleanup in case we got some error here. So I'm going to try to the build configuration to specify what kind of build setting here, and I also needed to delete just push the image. So I just need to delete the base image, OpenJDK 17, and then reader application. Okay. And then hopefully it's just cleaned up right now, and then back to the Kafka Knative project. And then once again, deploy this application. And then there are multiple steps. Actually, first of all, create the jar file, like a fast jar. And then the second thing is a containerized application using existing Docker file. And also you can use some like a source to image process and running on OpenShift. You don't need to use your local Docker environment. And then containerized application using Docker or Podman. And then we're going to push that image into specific container registry. In this case, OpenShift cluster provides integrate container registry, but you can also push it into Docker Hub or Google Container Registry or your own container registry based on you can set it up. Where is the container registry on my application property? And then once we push that image, it automatically run that Kubernetes YAML file. When I go back to project, and then under the target directory, and the Kubernetes directory. Now you can see Knative YAML file automatically generate. Why is this automatically generate? Because I set it up here, one line here. Kubernetes deployment target is equal Knative. It literally makes generating my new Knative YAML file. Let's go back to here, and then I need to create Kafka source. Just Kafka source, and then create Kafka source. And then the new Kafka source attach automatically here. And then give it a few moments because the Knative project, there are some default configuration to scale down to 0 time period, which is 30 seconds. So let me try to make sure this application actually Quarkus. You can actually deploy many different type of application runtime, like a Spring Boot and then like a Python, Java, .NET, etc. So it will scale down to 0 in a second. And then when I go to logs, you can find the same the version of Quarkus and a little bit faster startup time because it's serverless. And then if you deploy this application as a native executable, it's pretty much faster than like some millisecond startup. And in the meantime, so my application terminating, which means it's gone in a few seconds. And so once it's gone, and I'm gonna run the same performance batch job here. And then let's try to take a look at how fast this application scale up based on serverless workload. Now you can see there's no pod anymore. I don't even create like a HPA auto scaling. I don't even need to create like a KEDA stuff here. And then I just create a new batch job. And then now you can see the 5 jobs just are created, and then it's generating new dummy record. And then once the dummy record, and then pushing into my Kafka cluster, and then the Kafka cluster messaging sending to Kafka source, and the Kafka source to sending back to my application. And now you can see my application scale up, literally like an Amazon Lambda. And then when you go back to the application logs, you can find that Quarkus is pretty much busy to process the dummy record right now. The problem is here, even if it takes up 10 minutes, this application from 0 to 1 to scale up like a serverless. However, it's not going to scale up to maybe 10 or 1,000. There is some challenging for using like a serverless Knative here. So that's the reason why. So the goal of this session today is we're going to really more focus on event-driven serverless and auto-scaling. Not just scale from 0 to 1, it's more like 0 to like a 10,000 or a million based on event-driven storming or streaming from external services, how to do that. So luckily, we got some new sandbox project to integrate Knative and KEDA. So you don't need to select one of them anymore. You just use both at the same time, more flexible, dynamic, event-driven auto-scaling in your Java application right now. And the KEDA can be used auto-scaling Knative eventing infrastructure, which is the today demo, Kafka source. And then there are more source image, for example, like AMQ streaming and AMQ messaging broker, and then like the other Rabbit MQs and then Redis streams, etc. And then we have it's a final redesign architecture for auto scaling stuff. As you can see, pretty much it will be complicated. I know that, but KEDA still scrap and gathering data from Kafka cluster. In the meantime, Kafka sending out messaging to not application is Kafka source. And the Kafka source just sending back to that message in application using Kafka, the Knative eventing. And then Knative finally scale out your application with the combination KEDA, Knative. It allows you scale not just one, it's more like more than one, like 1,000 or even million based on your setting. So let's go back to here. It's my final demo, and then here is just still like one pod, and I change my last namespace, which is Kafka, KEDA, Knative, and then once again change my project, Kafka, KEDA, Knative. And also, I need to change it small, fix my application here. Go to application. I need to change it the right namespace here. So KEDA, Kafka, KEDA, Knative. And then here is the Knative configuration here also. So this is one of the feature of KEDA Knative integration. You can actually set it up min-max or Knative right now. Previously, you cannot do that. It's only scaled to 1. However, now you can scale. You can define the maximum scalability, like 10 or 1,000, as long as your Kubernetes allows. Let's save a file, and then I'm going to deploy this application once again. And then I also need to create Kafka source again. However, in this case, we got a little bit different configuration. This is another feature of this KEDA Knative integration sandbox project. You can set it an annotation here, and then you can set it up here. Pretty much easy KEDA configuration here. You can set it up like a polling internal, and then like a min-max for the KEDA as well. So this allows you integrate KEDA, Knative, managing your auto-scaling based on external event streaming, and then like from 0 to 10, 0 to 1,000, 0 to million, based on your incoming network traffic. So I just copy this one, and then once I deploy that, and I'm gonna back to here, and then attach that Kafka source right now. In the meantime, let's go back to just take a look at the HPA project, and the job is done. And my application go back to 1, just literally the process all 5 million. And then what about the KEDA? So there's no job, and then KEDA is go back to 0, just like that. And then Knative is scaled to 1, and the job is done, but it's still up because when you go to application logs, and then it's still bunch of jobs still working. Because the previously like a 10 pod parallel process 5 million job. However, this one pod needed to process 5 million alone. That takes some time to scale down to 0. So it's not like a perfect architecture to save your cost. The reason why you're gonna take the serverless architecture on your Kubernetes or like Amazon Lambda, you need to save your resources and power and the money as well. However, it's really spend a lot of time and resources, even if you run this application as a serverless. So let's go back to the final project here. And then the application is deployed. And then I just create the Kafka source. And then one last job here. And then let me give it some moment to scale down to 0. And then I'm gonna try to create the bash job again. And then you will find out how fastly and then flexibly this application pod, Java application scale in and out. The previous KEDA, it takes some time to scale out. And then like a 4 and 10, just like that. Once you scale out, and then it takes some time monitoring when it actually scale in again. But with this architecture, it actually handles eventing as well as the application itself to processing the event messaging. So that's why it's more flexibly scale up and down or in and out. Okay, the application is down right now. And then create a new batch job here. And then it will scale up in shortly. And then because the job is just created, and then it after a couple seconds, it just generates new dummy code, and now you can see the application is scaled up, and it's literally scaled out to 4. So KEDA, it takes out like maybe 10 seconds or 6 seconds to start up, and then it literally scale in 4 and 5. And then if you take a look at it a little bit more, and then it actually scale up and down really fast and dynamically based on the time of the processing your event-driven messaging. So it's already 5, and then if you go back to here, it's a little bit changed there. In the meantime, I gotta just finish up my slide and then go back to the question page. So here's a more auto-scaling Kafka source, like the sourcing event, Kafka source and the AWS SQS source, and then Redis streaming, and then also a Redis MQ broker and Redis streaming as well. And then a few takeaway today. So you can use KEDA for non-serverless application for event-driven processing. You can use Knative for event-driven for like a serverless, but not perfect cases because it's only one application. So you can actually use both in the integration. So currently, this integration project only scale out based on Knative event infrastructure, which is a Kafka source, for example. But we're gonna some roadmap to connect to managing Knative service serving directly, which means you don't need to Knative eventing anymore, which means it pretty much faster and dynamically auto-scaling in and out. So here's my YouTube channel. I already posted this same demo video. It's some separate demo. If you wanted to revisit and watching this kind of stuff, yeah, feel free to subscribe and add some comment. Hey, Dan, I need to learn more something new, and I'm more than happy to address that. And then here is some contact information about Quarkus project. One interesting is if you create a pull request, just one pull request, our Quarkus project, and then once that pull request submerged, we can give you like we made a Quarkus t-shirt. Currently, I wear the Quarkus 2, and then my fellow friends in the Rustam, Matt, they actually have a Quarkus 3. The t-shirts, and then whenever we release a major Quarkus project, like Quarkus 3 and 4, we're gonna give it away that t-shirt as our respect committer. That's it. And I'm gonna back to the last visit here. And then it's already scaled down to 2. It's pretty much fast rather than the other auto-scaling architecture. I'm gonna visit to here. Some question. It's also free, the LOSA option. So the LOSA, so when you deploy this kind of stuff to LOSA, it's pretty much the same. There's no charge. It's the same thing. It's literally you can go to just vanilla OpenShift cluster or LOSA, whatever you call that. Even the Kubernetes cluster is almost same thing. But there's no option for free, like a developer sandbox free, but there's no free for LOSA at this moment. And then, is there any standard way HPA via customer metrics, how many messaging or consume instead of adding yet another operator for KEDA? So there's no standard way. So you can actually create a custom metric. I showed that earlier, but so there are no specific capacity, how many messaging you can consume based on that message. So based on, you can set it out request limit and request on your application part and the metrics. But once again, you can only enable one metric adapter in the single namespace. You can allow the multiple adapter enabled in a multiple namespace, but you cannot enable multiple namespace in one single namespace. Can you automate it from 0 Quarkus instance using KEDA without Knative? Once you scale down to 0 without any incoming traffic, and then you can invoke that application, it will scale up from 0 to 1 or 0 to 10 based on your setting min-max. But that's not called as serverless. Because serverless is going down to 0 without any kind of incoming traffic. But to do that, you actually call just at once, and then it will have a similar behavior like a serverless. But we're not going to say it's a pure serverless architecture with only KEDA. If our instance scale up quickly, and what we still have to wait for partition rebalancing until a container is assigned a partition. It depends on so the what kind of architecture you're going to use, KEDA or just on HPA or like a HPA, KEDA and Knative integration as well. But the Kubernetes, as long as you're going to deploy application on top of the Kubernetes actually manage your rebalancing for network traffic based on ingress controller. So we're going to invoke from service level, and the service level rebalancing your autoscaling. I mean the partition stuff. Is the upper limit of how many concurrent listener we have the number of partition. So there are no explicitly upper limit on your concurrent listener at this moment. But it depends on what kind of external service you're going to use. Today I'm going to use Kafka source. So you can actually set it up like unlimited, like maybe 1,000 or even million, as long as your Kubernetes resources allows that. Okay, if you have more question, feel free to reach out to me and after this session. And then thanks for joining today. And enjoy the rest of the conference. Thank you.